This is project 2A PageRank, where we were supposed to rank a number of different pages contained within a corpus by their relevance. So this is the first corpus, which had 4 pages, HTML 1 to 4, and as you can see, I added 2 lines. The first line telling me how many duration it took for the PageRank value to stabilize, which in this case took 12 iterations. And stabilizing simply means that it didn't change more than, I think it was, by a value of 0.001. And the second one is just a checkup to see the total sum, which should be summing to 1 like it does. Alright, so this is the second sample set, which had 7 pages, and it took a bit longer, 14 iterations here to stabilize. And finally, the third data set with 8 pages, and here it took even a bit longer, 22 iterations to stabilize. Alright, so this is the code. I didn't change anything up here. This is the transition model, where basically we should distinguish between pages which do link to other pages. In that case, the total probability is made up of 2 different probabilities: a random probability, which is 1 minus the dampening factor divided by the total number of files within the corpus. And the second probability is the specific probability for that specific page, which is the dampening factor divided by the total number of links from that page. Now, of course, if the page has no links, then the specific probability would be 0, and the probability, so the total probability, is simply the random probability. And as you can see here, for the iterate PageRank function, I added a variable called iterations, which increments by 1 every single time this loop runs. So it checks if the changes for the PageRank value are larger than 0.001. And if it's smaller, then the loop stops. So I'm counting the iterations that happens, because as you can see here, this is the code line that I added for printing out the number of iterations it took for the PageRank value to stabilize. And then here's the sum. And that's pretty much it.